Okay, so to explain this properly, I had to add a little bit of notation to this problem. So you notice that for angle y, I added a 1 and 2 to distinguish between this part of the angle, this angle right here, and this angle here. Same thing for at vertex w. There's angle 3 and angle 4. And so here, I put w3, I'm talking about this angle here, and for y1, I'm talking about angle 1. Okay, so let's go ahead and fill in what are the congruent parts. So for angle x, that's this angle, we're given by the picture that it's congruent to angle z. That's given. For this angle right here at w, and I call it w3, what do we know about that? Well, notice that this side is parallel to this side. And what do we remember from chapter 3? If we have two lines or two segments that are cut by a transversal, and we're given that these are parallel, then all four of those theorems that we just learned from chapter 3, they all apply. The alternate interior angles, the alternate exterior angles, the consecutive interior angles, and the corresponding angles. So angle 3 and angle 2 are what kind of angles? That's right. They're alternate interior angles, and we know that alternate interior angles are congruent given that these two lines are parallel. So angle, what I'm calling angle W3 is going to be congruent to angle Y2. We also know that angle 1 and angle 4 are also alternate interior angles, so they're going to be congruent. Okay, so what about the sides? XY, this segment, has two congruence marks. We can see that it's congruent to the bottom side here, WZ. And then YW is right here, and it's congruent to itself. And then angle X, not angle, but side, segment XW, right here, it has one congruence mark, and we can see that it is congruent to segment YZ. Now we didn't fill in all the reasons except for the very first one I wrote given. Okay? What are the reasons for these 5 other things? Go ahead and try to fill those in.